All right, here's another example on graphing rational functions. So step one is we're going to find if there is symmetry. So we're going to evaluate the original function for negative x. So we're going to get in the numerator 3x squared, in the denominator x squared minus 4. And what we got is the original function back. So this is the same as that. So that's telling us that there is y-axis symmetry. So if here is our y-axis, there's going to be symmetry about here. All right, step two is to evaluate the function for 0. So we have a y-intercept at 0, 0. Next is to find the x-intercepts. So we're going to set the numerator equal to 0 and solve for x. So we'll divide by 3, square root it, and we still get 0. So the x-intercept is at 0, 0. To find the y, or the vertical asymptote, we're going to set the denominator equal to 0 and solve for x. So we're going to factor this using the difference of two squareds. Then we're going to use the zero product property. And solve for x. So we get x equals 2 and x equals negative 2. So those are where our vertical asymptotes are. There are also our domain restrictions. The next step is your horizontal asymptote. So we're looking at the degree of the numerator and the degree of the denominator. They are the same. So we think about the leading coefficients 3 and 1. We have to divide them. So we have a horizontal asymptote at y equals 3. We're going to skip 6 for now and come back to it. We're going to start to graph all of the pieces to our function. Okay, so step 1 says there was symmetry about the y-axis, so we'll keep that in mind. We're going to move on to the y-intercept is at 0, 0. The x-intercept was also at 0, 0. And then we have vertical asymptotes. At x equals 2. And x equals negative 2. We have a horizontal asymptote at y equals 3. So far we just have one ordered pair on the graph. So that's going to bring us back up to step 6. We're looking to find some additional ordered pairs around the vertical asymptotes and the x-intercepts. So we're going to probably need to evaluate the function over 1 and negative 1, and then maybe 3 and negative 3. So I'm going to start off with f of negative 3. And when you're done, you're going to get 27 fifths. Well, 27 fifths is really hard to graph. So think about 25. 25 fifths is about 5, so it's a little bit more than 5. So it's 5 and 2 fifths. Then we'll say f of negative 1. You would simplify it, and you get negative 1. So you have an ordered pair negative 1, negative 1. And then we have f of 1. And we get the ordered pair over 1, down 1. One more, f of 3. And we get 27 fifths again. Okay, so let's go ahead and graph those 4 ordered pairs. So I'll start with negative 3 up 5 and 2 fifths, negative 1, down 1, right 1, down 1, and then over 3, up 5 and 2 fifths. Okay, I'm going to go to, let's do maybe black. So there was y-axis symmetry. So this graph, in between those asymptotes, if we think about folding that y-axis along a piece of paper, they'll mirror each other. And then in the pink up here, it's going to come down and go along those 2 asymptotes, the vertical and horizontal. And then same thing here. So that's how you can graph a rational function.